the pelleting process or extrusion process, we try to put all things together, not only by the force from outside, but also by the forces, all the particles, they bend each other. Is the bending properties. So how can we get the bending properties, the most important?
Welcome to the Feed Science Podcast. I'm Adam Farnells, coming from North Carolina State University's Animal Food Manufacturing Program. Thanks for joining us. On behalf of Wisenetics, we appreciate you watching and or listening to this podcast and hope that you like, subscribe, give us suggestions. We're always interested in seeing what you guys as an audience are interested in hearing more about. My guest today is Hongyuan Cheng. He's a process engineering consultant working in the areas of feed manufacturing optimization. Hong, thanks for joining us today. It's great to have you.
Thank you. Thank you so much for the introduction.
Yeah, you bet. If you wouldn't mind, introduce yourself a little bit more to our audience. Give us kind of your background and what the kinds of things are that you work on.
Yeah, just like you know, my name is Hongyuan Cheng, but people normally call me Hong around the Nordic countries. I mainly work locally in Denmark. I was graduated as a chemical engineer with in the Technical University of Denmark, and it's located in a small country. And after I graduated as a chemical engineer, so I was graduated. I took my PhD degree at the chemical engineering department of the Technical University of Denmark. And after that, I joined the National Food Institute. I started with the food business, with the dairy, with the juice, with the different kind of the food processing process, and in some cases we started to work with the extrusion process. And then the extrusion process, we found out that there's more challenges in the fish feed production. So after that, we moved to the fish feed production. This is the main reason. Another main reason is in Denmark and Norway, there's very strong aquaculture industry. So there's very strong industry need. So they need to understand the behavior of the factory, the function of the production line. That's why we use a lot of energy to the fish feed production and also for the feed mill production. There's another thing is there's also one very famous feed production line design company, Green Tech, located in Denmark. They also need such kind of knowledge, and how can we understand all the process, not only by experience but also by some kind of numbers and theory.
Deep in the jungle, nature holds the secrets to healthier, happier chickens. Science is unlocking those secrets with Optient, the revolutionary lighting innovation for poultry farming. By mimicking nature, Optient gradient lighting creates a unique floor-level lighting gradient that improves feed conversion by up to 4 points, slashes energy use by 70%, and keeps flocks calm and stress-free. That means better animal welfare and a more efficient farm. Want to learn more? Optient gradient lighting is now available exclusively through your local Valco dealership or email optient@val-co.com today.
What we're going to cover and talk today is a lot related to that particular topic, and that being that for a long time, and it still happens a lot today, especially in older facilities and things like that, we focus a lot of our ability to manufacture animal feeds based off of long-term on-the-job training and skills, and to some extent what we refer to as the art of feed manufacturing, and just kind of more or less kind of thinking we know what's best. And in today's world, where we've got more automation and more ability to collect data, there's an opportunity to do more optimization of the process by collecting this data. So I'm curious, in your particular experience, where are some of the like best places to start in order to use data tools to collect information and then use that to optimize the process? What gives us some of the best return on investment in using data to make the process better?
If we see the feed production line, we can see there's also different kind of there's a different kind of unit, from the receiving and then the weighing and then the mixing and then the pelleting, and then with all the process. Typically, if we get something written, I think the best place or best unit we start is to work with the pelleting machine or the extruder. After that, we expand the analysis to the drying or the cooler, and then to the preconditioner, to the mixing, and with all the different kind of things. But with I think if you get a return, probably the most important thing is you first understand the pelleting or the extrusion. But the pelleting, typically the people say, "Oh, pelleting is important." The pelleting is not that for the whole production line. The pelleting probably only 20% of the function, or another 80% is goes to different places. For example, preconditioner. The people also suggest to play 20% of the function, and then of course the recipe, the raw material, probably the most important.
So when we talk about, pelleting being a good place to start on something like optimization, and modeling and trying to find more efficient ways to do things, why is pelleting the place to start? Is it because of the number of inputs and the amount of energy that's used in that particular process that makes it so important as a place to start in the optimization ideas?
The pelleting is simple, but when we change the raw material, when we change the raw material, we are not only change the name of the raw material, but we also change the processing properties of the whole recipe. So with the same recipe, but we change different materials from different sources. So we send the material to the pelleting machine, so we will see the different result. And this is the reason. Another reason is after pelleting, we are getting products. If you start observe other places, actually you don't know what will happen with the final products. But if you focus on pelleting, you can see right away the pellet quality, and then you can go back to the different unit operation to analyze what was the reason for us to get such pellets. That's the reason.
And I suppose this would apply not only to pelleting. I suppose it would apply to other places in the process as well. But in order for us to properly optimize the process, we obviously need to be able to develop some sort of models for it. And in order to model it, we have to have data. So in your experience, what are some of the challenges for feed mills or aquaculture production facilities? What are some of the challenges for them in actually collecting the data they would need to even begin to generate these models for optimization?
The most important thing is how can we understand the process, but from our group, including me and another guy from Nofima in Norway, and another and the guy is his name is Cho, and then he's a person from Nofima, and one professor, Matt Johnson, and she's from the North University. We suppose that typically the people understand that concept. We suppose the process is the pelleting process or extrusion process, we try to put all things together, not only by the force from outside, but also by the forces, all the particles, they bend each other. Is the bending properties. So how can we get the bending properties? The most important. The bending properties is not easy to measure, but the people normally through measure the viscosity. Yes, the people typically measure the viscosity. But when we measure the viscosity, normally we measure that kind of thing in lab. In lab, we measure the viscosity is in the lab situation is at the atmosphere, the surroundings, and we can easily rise the temperature, but not quite that easy to simulate the pressure within the pelleting or the extrusion. But of course, some commercial companies, I'm not going to say their name, they have made all different kind of efforts. They have also invented some kind of devices in use, but still is in the very beginning, that kind of devices. We are still work with that kind of devices in the trial and error process.
I think you've touched on something really interesting there in the pelleting process, especially, and we see some similar things in grinding or batching and mixing, where there are some things that we know how to measure. We know how to measure energy consumption. We know how to measure steam production. And then on some things, even on physical or chemical traits, we know how to measure moisture addition and things like that. But even after all of these years and lots of research, there is still a lot that's left unknown about things like binding properties of materials, or in mixing, let's say. There's been a lot of work on powder and bulk solid handling to talk about how different particles and materials mix together. But a lot of that work is done in the food side or in the chemical side, where things are very uniform compared to some of what we try to do in animal feed, with lots of different ingredients and particle sizes and quality of, one byproduct on one day versus the next day. So in the idea of trying to create these models, how do we account for some of those things? There are some things we can measure well. How do we account for, in the models of trying to optimize our process, the things that maybe we're still struggling to measure? How do we go about incorporating that into our decision making?
If we talk about the binding properties, or we call the processing properties of the recipe, right now we can see if we cannot easily to measure such kind of binding properties, why not we can use another way. We first set up a general model, and then we have all the extrusion, all the pelleting data, and then we have the properties, and then we can use the general model to go back, and then we see the recipe with a different kind of a group. We can simply split the group. One group we call that is a bending group material. Another group we call that is a non-bending group material. We just split this one to two groups, and then we can use the calculation, some mathematical or skills to do such kind of things. There was some kind of efforts from a Norwegian company. They have made some kind of list to give all the bending properties a value for all different kind of material. But such kind of things, they say the value is only from the experience. But right now we are thinking maybe we should use some kind of calculation. For example, we use the machine learning or other techniques to achieve that goal. But we are working on that direction.
Yeah, no, and that's definitely the next direction I wanted to go. Real quick, once again, my guest today is Dr. Hongyuan Cheng. He is a process engineering consultant working in the Netherlands in the area of feed manufacturing and aqua feed. Oh, I'm sorry, Denmark. I got my Northern European country's messed up there. Denmark. We're in Denmark. Process engineering consultant working in the areas of animal feed production and aquaculture feed production. So you mentioned there something I think that's really interesting, and that is that going back to kind of the idea of, and pelleting, I think is as good of a place to have this discussion in the feed industry as any other process, although it can apply to things like grinding and mixing and all the different interactions that can occur. But in the pelleting space, we have a lot of different variables, environmental variables, and we have equipment variables. We obviously have formulation variables, operator variables, and I think the number of variables that go into something like the pelleting or the extrusion process are a lot more than people realize that there are. And then when we take something like, let's say, a binding characteristic, but this could also apply to something like a throughput characteristic or, a number of different other physical characteristics that we might be interested in. One thing I think that is not understood as well as we would like is all the different interactions that can happen, where if I am preconditioning at a particular temperature and moisture, this ingredient may increase binding in the pellet by 5%. But if I do it at a different moisture, this ingredient will now only increase binding by 2% because there's this interaction that's happening in there. But that's even going to be a little different if the condition of the pelleting die is older or newer, or whether it is a high throughput machine or a low throughput machine, and on and on and on, which means we have so many variables and we have so many potential interactions that it's very hard to do the math and everything on all of that, which is where things like artificial intelligence and machine learning can come into play. So I'd love to hear some more about things that you and your group have already started working on and using some of those tools to be able to take all of these different potential inputs and potential variables and see how they interact and how many data points that requires to begin to understand what's happening in the system.
When we collect all the different kind of data, the first we have to do the data laundry. But when we do such kind of things, we use some mathematical principle. Maybe you are not familiar with such kind of things. It's so-called dimensional analysis. The basic idea is when we write the formula, the dimension of the formula, the two sides should be homogeneous. They can delete each other. It's so-called dimensional analysis, or is also called scaling law. So we can put all the parameters together, or we say this is group, this is another group. And then we make the parameters a little bit less. And then we do the analysis. For example, we are use the Dow viscosity model. We built up a model to analysis the extrusion pellets properties. And then with such kind of things, we can simply reduce all the regression or estimation parameters from 12, from 10 to only 6. Of course, we made a lot of assumptions, and then we can make things simple. And then we test with all the different kind of data from well-developed pilot plant from Norway, mainly from three Norwegian pilot factories. And then we test that kind of things. We found out a very interesting result. And then such kind of things, the dimensional analysis, or called scaling, we can use the same formula to cross to the different kind of extrusion system, not only suitable for one system. For example, as the old-fashioned, it's not old-fashioned, not old-fashioned. If we use another correct word, is we use the classical, the data analysis method is called response surface analysis. If we do the data analysis, we get the result. It's nice result. It's a good result. but normally the results only limited to the studied cases. We cannot extend such kind of cases to another system, another extruder, another recipe. This is the things we do.
Yeah, I think that's one of the things that, the way that you're talking about approaching it and bringing in some of these ideas of models and particular types of statistical analysis, in addition to bringing in your case, an experience from the chemical engineering standpoint and thinking of it with all of the different interactions that might be happening inside of the processes. But even still, I think it's interesting that to get people to understand, and I think this is true in our own industry, in the feed industry, but also to people that might be outside the industry and think, with some simple things that we would do over here in this type of manufacturing industry, we can model the process. And then you find out that what works well in one feed mill on one set of equipment is not the same model. It is not the same equation. It is not the same predictive analysis that happens over here. And so everybody wants this idea of, give me the equation that will help me predict pellet quality. And the idea of that being anything simple is absolutely not the case because of all of the variables. So I think that's interesting, as you say. We've done it at these different pilot plants under a lot of control, and we're still finding differences, even though we used the same formulations and we thought everything was the same, and it still wasn't.
No.
I guess one of the questions then that leads to, and we're coming up on here on our 25 minutes or so we might make this the last one, is with all of those things in mind, what would be your advice to facilities and companies that would like to do this kind of work, that would like to start working towards modeling their processes? Where, if they're not already doing this, where should they start? Do they start with just collecting as much data as possible? Do they start with a specific question that they want to answer so they have a goal in mind? What's the best way for them to start going down this path of modeling for optimizing their processes?
Yeah, because the feed production line is also long. It's not that long, but it's not short. It's very long processing process. They have 6 or 7 unit operation or equipment. Maybe we can, if a company, if we use an engineer way to think about this such kind of things, we can this so-called engineer way. We set up something so we can repeat such kind of things not only for the one production line, but also we can move to another production line, all different kind of production line. Maybe we can just to do some simple things. For example, for the steam management, in the precondition we use a lot of steam, but how much amount of steam we should add into such kind of things? If we add more steam, and then it's waste of money. If we can save only 0.5% of steam, this is your factory's profit. Is not something in the heaven. You can save the money. You can save the payback right away. Maybe you start from simple things. And for the extrusion, for the pelleting modeling, a lot of people, they put efforts, but there's no. It's not easy job. For the factory, if we start to do something, it's easy, so repeatable. We build up engineer solutions. It's so-called engineer solution is with a big company, with one unit, with one production line, we made success. We can easily move this experience to another one.
I think, you know what? I think that's a great piece of advice. So we're going to do engineered solutions. We need to focus on simple problems to start and things that maybe don't require huge amounts of some of this data. Something like you said, like steam, and measuring how much steam is going in, as an example, and potentially create a solution, create an understanding of that small piece of the process, then move to the next one, versus let's try to solve all of the questions at one time, because that probably doesn't work.
Yeah, I think that's a good idea.
Okay. Well, I think this has been a really fun conversation, and I hope our audience found it to be that way as well. I think the idea of trying to consider these like engineered types of approaches to what we do in feed processing is really important, not just in engineering the facilities and putting the equipment together, but also how we actually run the equipment and looking for these optimizations. And you've given us some really good ideas of how we can go about collecting that data and doing a step-by-step process, and also to understand that there will be a lot of interactions, and what is a solution for one facility or one company may not be the same solution for somebody else. And the more we understand that, the less frustrated everybody will get with, the optimization process not working for them.
Yeah.
I really appreciate your time today. Again, my guest today has been Dr. Hongyuan Cheng. He is a process engineering consultant working in Denmark. I got it right that time.
Yeah.
Hong, thank you very much for your time today. I appreciate it.
Thank you. Thank you very much.
Once again, I'm Adam Fahrenholz from North Carolina State University. On behalf of WiseNetics, this has been the Feed Science Podcast. We hope you're enjoying the series. We are coming up somewhere near the century mark of our episodes, and it's been a lot of fun so far, and we hope it's been good for everybody in the audience as well. Please do like, subscribe, whether you be on YouTube or on podcast, and again, comments and let us know what you'd like to see more of would be great. And until then, until we have our next episodes coming out, we'll talk to you the next time.